Hey guys,
Best TAs here,
Ali
and Connor,
coming at you.
with another video.
This is going to be a review of the quiz from March 1st. So, the first thing we're going to do is we're going to look at r equals 1, c equals 1, and we know that m r of c is equal to 3. So the first thing we do is say m11 is 3. Now, looking in our while code, we know that m of 1 is less than 20, so 3 is less than 20. So we start looking at what our while code is actually doing. M12 is equal to M11 plus 7. So we know that M11 is 3, so M12 is equal to 3 plus 7, or 10. So now, looking at the actual output for M, or how it's stored, we know that the first value, M11, is going to be 3. We know that the second value is going to be 10. And we know that the third value is going to be 17. We know this because there's a clear pattern here. Every time the while loop runs, the next instance of M is going to increase by 7. So since MRC, M11, starts as 3, we add 7, and we'll add 7. Notice that we're going by column because we're increasing the column value. We're increasing C here. So in other words, we're going to stop when our code is 17 plus 7, or 24. So M comes out as 3, 10, 17, and 24. Now we know since the while loop ran 4 times, that C is going to end up as 4. And R never changes, so R is equal to 1. So now we're going to look at problem 2. The first thing we notice is that we're printing C and D. So here's our output right here, C, D, with a tab in between them. Now we notice that for our while loop, we have while C is less than or equal to 7, we notice that C is increasing. So let's count for C. We know that C is going to be 1, 3, 5, and 7. So we're looking at this if statement, and we know that the if statement is going to run when C is 3, when C is... And so we look at 2 times D of 3 is greater than or equal to what's on the right, sum of D from 1 to C minus 1, which in this case is going to be 2. So we know that the sum of D from 1 to 2 is just 3, and we know that 2 times D of 3, since D of 3 is 3, we know that's 6. So since 6 is greater than or equal to 3, we can run our loop. Now, the things we're outputting are the value of C and the value of D of C. So the value of C is going to be 3, and the value of D of C, D of 3, which is 3. Now we do the same thing. So when C is 3, C becomes 5, and then we look at the if statement again. 2 times D of 5 is going to be greater than or equal to the sum of D from 1 to 4. And we know that the sum of D of 1 to 4 is just 1 plus 2 plus 3 plus 4, so we know that that's 10. And 2 times D of 5 is also 10. Now, we notice that these are equal. So our code prints. We get 5 and 5 because D of 5 is 5, and at this point C is 5. But we notice that our code started as greater than or equal to, and then the next time we run it, it's going to be equal to. Now, we notice that the term on the right I'm sorry, the term on the left is increasing more than the term on the right, so we know that the next time our condition's not going to work. So we can show that here. 2 times d of 7 is greater than or equal to sum of d from 1 to 6. Now, we know that this is 14, and we know that this is not greater than or equal to the sum of d of 1 to 6, which is just 21. And so, we're done. Our answer to format correctly is just C, a 3 and a 5, and then D, a 3 and a 5.
All right, so now let's take a look at the other side. So right here we have a matrix A that is 8 cells long, and we know that our for loop variable k runs from 1 to the length of A in increments of 2. So every other value in A is what it's going to be checking. So we see that there's A of k here, and there's B of q there, so we know that A is going to be going from 1 to 3 to 5 to 7, while B is just going to be going from 1 to 2 to 3 to 4. So B of 1 is equal to A of 1, which is equal to 1. Then we run the for loop again, and so now we're going to be running B of 2 is equal to A of 3. And A of 3, in this case, is going to be 3. We run the loop again. We're going to be checking B of 3 is equal to A of 5. And A of 5 is just 5. And then B of 4 is equal to A of 7, which is equal to 7. Now, the for loop isn't run anymore because it's reached its the length of A. So we stop that for loop. So then we get B as the full vector is 1, 3, 5, and 7. Alright, so now let's take a look at the last problem. So we can see right here that M is going to go from the length of C to 1. So we can see at the top that the length of C is going to be 4. And so generally, when you write an increment like this, it assumes that the incrementing is going to be as a positive 1. So now you can't go from positive 4 to 1 via an increment of positive 1. It would have to be a negative 1 or something like that. So thus, there's no actual way that you can reach 1 from negative 4. So this would actually result in an error. So now, if you did 1 to the length of C, then you would actually be able to run this this loop. This is actually something that's new to MATLAB. Now, whenever you have empty cells inside a matrix with the other cells around it defined, it'll fill them in with zeros. So we can find D of 1 is equal to C of 1, which is just 1. And then D of 2 is equal to C of 2, which is 2. And then D of 3 is equal to C of 3, which is 3. And then that would go until the length of C, which is 4. So this top one would result in an error, but if you were to switch around the variables, then it would result in a vector that looks like this. So D is undefined,